Hi everyone, so this is Potrero Chico, and if you're not familiar with this place, it's a unique geologic formation that's really close to the city of Monterey. So I first heard about Potrero because it's super famous among rock climbers because it's got these really long multi-pitch climbs. And Alex Honnold, the guy who is famous for climbing big walls in Yosemite without a rope, well he famously soloed a 15-pitch climb here. So whenever I got to visit a couple weeks ago, one thing I realized was that there were a lot of people curious about how all of this came to be. And as a resident geologist, my friends asked me to explain the geology of the area to them, and I did my best, but I figured a more visual, video-style answer would be even better. And I figured other people would probably want to know what the geology of this place is too, so this is my attempt to describe the age-old story on how Mother Nature produced this unique sport climbing paradise. And to start the story off, we're going to have to travel back in time to about 200 million years ago. So, if you went to a Texas public school like me, you were probably in your 6th grade science class when you first learned about the supercontinent Pangea. Well, before the breakup of Pangea, the Gulf of Mexico, which is known for its beautiful and serene beaches, didn't even exist. But when Pangea began to break up, the area between the North and South American plates stretched and thinned to create a perfect little bowl for seawater to flow into. And since it was super hot at this time, that seawater would evaporate and leave some salts behind and then fill up again. And this process would repeat over and over until eventually there were these massive deposits of salts like halite and gypsum. And in some places, these layers of salts were about 4 kilometers thick. Now, while all of this salt was forming, the plates were still moving farther and farther apart until eventually the tiny little bowl turned into an open gulf. And the sea level also rose a lot, so this changed this whole area of Mexico into a shallow sea. So when this area turned into a shallow sea, it looked a lot like what we see in the Bahamas today. There were these huge coral reefs, except the reefs weren't made out of modern coral. They were instead made up of extinct mollusks called rudest clams. That's so hard to say. But since this area was covered by a shallow sea, lots of limestone and other carbonate rocks were formed on top of the salt. And limestone forms when tiny sea creatures die and fall to the bottom of the ocean. And over time, as more dead sea creatures and their shells get piled on, it compresses into the hard rock that people are able to climb on today. But when you look at limestone, you're probably not going to see any obvious shells. I mean, there may be a few here and there, but that's because the creatures that make up the bulk of the limestone are actually so small that you would need a microscope to see them. Okay, so now we have fast forwarded to a time that takes place after the asteroid wiped out the dinosaurs and the rudest clams. The polite ones stayed behind. But jokes aside, the rudest clams became extinct, and that paved the way for modern coral to take over, basically. So the planet looked a lot like this, with the Farallon plate converging with the North American plate. And if we fast forward a bit, you can see that this is what formed the Rocky Mountains and also the Sierra Madre Orientals. And what's cool about the Sierra Madre Orientals is that they clearly show what happens whenever two plates crash into each other. The rocks will literally bunch up like the front end of a car during a car wreck, except the Earth's plates do this slowly. So you get nice little folds as if the Earth's crust were a rug being pushed up against a wall. And when the Farallon plate was crashing into the North American plate, it pushed and folded all of these limestone layers and salt into mountains. And Potrero Chico is just one of these folded mountains, and technically it's what geologists call an anticline, which is a folded package of rocks that forms an arch. And interestingly enough, there is another anticline nearby, and it's called Cerro del Topo Chico, which should ring a bell if you like the sparkling water. I've always been a little confused as to why Topo Chico would name their company Little Mole, but it makes sense now that it's just the shortened version of Little Mole Hill, which is supposedly the anticline that the company sources their water from. But, I don't know, Coke acquired the company in 2017, and they've been seriously ramping up production, so I doubt they still source all their water from this tiny little hill, but anyways. So after the plates crashed into each other, something interesting happened with all the salt that was deposited. So salt is a lot like most people. Whenever it's under a lot of pressure, it gets all squishy like putty, and then it likes to move to spots where the pressure is not so intense. So here at Potrero, the salt, which is less dense than the overlying limestone, started to rise up like a lava lamp. And as it was moving itself up, it pushed the overlying limestone up even more vertically, super high into the air. And this is partly why the limestone here is perfect for long, like up to 25 pitch climbs. And here at Potrero, the salt has even made itself to the surface, and you can apparently find salt in the middle of the Potrero. So over time, erosion has molded and shaped the rock layers into what we see today, and if you look at Potrero in satellite imagery, it looks a little unusual. It's more of a bowl than a straight up mountain, and I was going to create an animation that shows how erosion can produce these corral-like features, but luckily I found a tool online where you can input a bunch of layers like the salt, the Cupido limestone that forms the walls that everyone climbs on, and all the stuff that was eroded away. And you could show what they look like, what these rock layers look like when they get folded. And then you can see how these rock layers would look like if they were eroded into a hill or a valley. And if I roughly estimate the topography of this area, this program produces two little corrals that we can see from above. And so that is how we get this mecca for sport climbing. Luckily, we know how this place was formed because there's been a ton of geologic research in the area, and that is mostly because a lot of the world's oil and natural gas is found in areas where there's a lot of salt, like in the Gulf of Mexico and in the Middle East. And so naturally, oil companies are going to want to fund university projects that help them understand the geology and how oil gets in specific places, and also how to find more of it. And as a side effect, we get to learn about other cool structures that are formed in the process, like Potrero Chico. So anyways, a lot of specific events had to take place in order for this big wall sport climbing utopia to even exist. And hopefully this video gives you a better understanding, or at least an appreciation of how all of this came to be.